This time we'll have a function involving square roots. So again, think about the domain first, and we see that two rules of math can possibly be broken with this. One, there is a denominator, so it cannot be 0, and two, there is a square root, so its contents cannot be negative. So with this function, we will be out of the domain if 1, the 6x plus 12 cannot be 0 since it's in a denominator, and 2, it cannot be negative since it's in a square root, so we will be out of the domain if 6x plus 12 is less than or equal to 0. Move the 12 over, divide by 6. So we're out of the domain for x less than or equal to negative 2. Meaning the domain will be everything but these values. All right, so now we know where this function lives, the domain. We can find where it's 0, positive, and negative by setting the original function to 0. And solve. Okay. So in general, if you're trying to solve an equation for where it's equal to 0 and you have functions of x in your denominator, what you should do is multiply both sides of the equation by the least common denominator. Alright. Least common denominator distributed to the first term on the left. The square roots will cancel out, leaving a 4 and 6x plus 12. Least common denominator times the second term on the left cancels out the denominator, leaving 12x's. And anything times 0 is 0. Distribute the 4. And collect like terms. And both 48 and 36 have 12 as a factor, so negative 4/3. Okay, so this is the only root. All right, so now on a number line, I'll place my root of negative 4/3. But also include your domain restriction. Remember, this function does not live for values of x less than negative 2, so we cannot go beyond here. Okay. Now, you can do this with a calculator, but watching me type stuff into a calculator won't help. Yes?
So, you always include the domain restriction, or is it only for that?
You always include the domain restrictions for where a function on your number line is. Because if x is less than negative 2, we have a negative inside of our square root, so there are no y values. So you can't say the function is positive, negative, or 0 if you're less than negative 2. So, and that's what we're looking for. So if you use a calculator, you could just pick a number between negative 2 and negative 4/3, plug it in, see if you get something positive or negative. What I'm going to do is I'm going to use more or less an argument. I'm going to imagine we're really close to negative 2, but bigger than it. If x is really close to negative 2, 6x is really close to negative 12. So the contents of the square root is really close to 0. So this term is not going to be very important. If x is really close to negative 2, this numerator is really close to negative 24, and we would have a denominator that's positive but very, very close to 0. So we see that something close to 0 plus something extremely negative will be negative. If you don't like this algorithm, just stick it into a calculator. If x is bigger than 4/3, I use 0. If x is 0, this whole term is gone. If x is 0, we get 4 times the square root of 12, which is some positive number. So give your answer an interval notation. So f is less than 0 from negative 2 to negative 4/3, and f is greater than 0 from negative 4/3